Here are a few examples from the 12.1 homework. So, remember 0.25 is 1/4, so I'm going to replace 0.25 with 1/4. Because we know that with cosine, it's adjacent over hypotenuse, so it'll be easier to understand this if it's written as a fraction. Alright, so secant of theta, since they have the same angle, we know that they'll have use the same triangle and the same angle of that triangle. So if I remember, secant is just the reciprocal of cosine. I know that it is hypotenuse over adjacent, 4/1, or 4. Alright, number 5. Well, let's actually do number 7. Alright, so pi halves to pi. Angles. Okay, so they're talking about radians, right? So whenever we have a measurement that uses pi, we know they're talking about radians. So this would be 0 radians. This would be pi half radians. And this would be pi radians. Okay, so we know that we're in between pi halves and pi. We're over here in the third quadrant. So I'm going to build a triangle. All triangles use the reference angle, like we learned before. And here is the angle that I marked there. So that will be sine, which is opposite over hypotenuse. So the hypotenuse is 17. And the opposite is 8. And then, I've got to find my calculator, because I haven't done this one yet. We've got to figure out what that missing side is. So, I'm going to do a squared plus b squared equals c squared. And get out my calculator. Okay, so 17 squared is 289. And then 8 squared, of course, is 64. So I'm going to subtract 64 from both sides. And then take the square root. So I'm taking the square root of 225. Sorry, not used to this calculator that I'm using. 225, take the square root, I get 15. Okay, but this is important. I wouldn't give you that information if you didn't need it. So because we're in the third quadrant, notice if I move this way that I'm highlighting on the x-axis, that's a negative direction. If I move up, that's a positive direction, so 8 stays positive. So we have a triangle with one length of negative 15, 8, and 17. So I already have sine, which gives me cosecant. I didn't even need to do that actually. Cosecant is just the reciprocal. Cosine will be adjacent over hypotenuse, which means secant will be hypotenuse over adjacent, and tangent will be opposite over adjacent, and cotangent will be the reciprocal. So I don't even need to look at the triangle on that one. So these are there mainly to let us know how to draw our triangle and what's positive and what is negative. Alright, these down here should be fairly easy. So cosecant is hypotenuse over the opposite. We don't have the hypotenuse, so we'll need to do the Pythagorean theorem, but you're going to get 5 there. So it is 5 over, opposite is 4. Alright, so other examples, trig ratios. We need to simplify. So simplify means to make it less complicated. So if we look at 25 here, we have a lot going on. Cosecant, cosine, tangent, right? So if you remember, we learned a property that tangent is sine over cosine. So let's go over those real quick up here. Tangent equals sine of theta over cosine theta. We learned that last unit. We reviewed it last class. We also learned that cotangent, since it's the reciprocal of tangent, will be cosine theta over sine theta. And we learned that sine is the same as 1 over cosecant because of the reciprocals, and cosine will be the same as 1 over secant theta. All right, so that'll help us on these. So cosecant is the reciprocal of sine, so I can write it as 1 over sine, and then I have cosine. These are all held together by multiplication, of course. So the cosines cancel out, they divide out, the sines divide out, we're left with 1 over 1, which this simplifies down to 1. And that's all you do, okay? So look at this one right here. 27, we have sine squared theta, and then cosecant will be sine, 1 over sine, so I can write it like that. And then secant will be 1 over cosine. So sine squared, I'm going to rewrite as sine times sine. All right, so one of the sines cancel out. Sine times 1 is 1. Sorry, sine times 1 is sine. Times 1 is still sine. So we're left with sine theta over cosine theta, which, if you remember, is tangent. So that's the simplified form of that. Meaning we could put all these in our calculator with 30 degrees or 40 degrees, and it give us the exact same thing as if we put tangent of 40 degrees. But this is easier to use in our calculator than this, so that's why we prefer this.